And for the new folks, if you're not aware of who all we are, we're the American Association of State Climatologists. We're basically a professional association for state and service climatologists, which are essentially applied climatologists. Many state climatologists in our realm, as you would think, but also people from the regional climate centers, our federal partners, people on their staffs, people from NIDIS and other partners that we work closely with. So we're glad to have you on board. I'm the executive director for the association. And then I think what I'm going to do right now is go ahead and introduce the president of our association, Leslie Ann Dupuis-Giroux. She is our president. She's also the Vermont State Climatologist. And so Leslie Ann, if you want to go ahead and take it away, please do.
Thank you, Glenn, and a hearty welcome to everyone. I don't know if it's raining in your neck of the woods. It's a little bit cloudy and rainy up here in Vermont, and it's so nice to see so many faces, both familiar faces, but folks who have yet to meet and hope to have become familiar faces as we step on through. So welcome, everybody. Particularly excited to welcome Adam Smith from the National Centers for Environmental Information. And he's going to be talking to us a little bit about the $1 billion disaster product, which comes out of NCEI. It's one of those that brings together a lot of information, a lot of data in a way that includes not just the natural sciences, but also the socioeconomic pieces of the puzzle. And so I'm really excited to hear a lot about the various things that are coming down the pike and the ways in which we can use some of these tools in our own work. So with that, Adam, please take it away.
Good afternoon, everyone. Let me share my screen and get into this talk. All right. Yeah, so today I would happily present to everyone kind of a big picture overview, but also going from the macro to the micro scale as far as all the different data sets and tools and products that come out of this disaster platform. So the U.S. $1 billion weather and climate disasters has been going on since 1980. At first it was at the NCDC, but now it's NCEI. And what the impetus for this research is to provide a various number of users with different backgrounds and different questions, a better understanding of U.S. disaster costs over space and time using different charts and tools in the data itself. So let's get into the talk. So here's an outline. First, I want to provide some broad context regarding what we're trying to measure and why we're trying to measure it. Secondly, we'll talk about the data sources, the public and private data sources that we leverage for this, and the different variables. The third and the fourth section, though, is really the meat of this talk. First, we'll go back through what happened briefly in 2019, because that was quite a year, but also in 2020, this year, is yet another extreme year for the United States for a variety of weather and climate related events. And finally, I think most importantly to this group, the disaster costs, comparisons, the tools, what we're thinking about in present and future to make your jobs perhaps more easy and make your analysis more interesting and to illuminate different questions that you may ask. So let's get into it. So NOAA's NCEI has a statutory mission to describe the weather and the climate of the United States. And effectively, we're like the nation's scorekeeper regarding many different trends and anomalies. And as you all well know, we have hundreds of different products and services that look at different angles of the data ecosystem. But as a smaller part of this broad responsibility, again, since 1980, we've analyzed extreme weather and climate events in the United States that have great economic or societal impact. And colloquially, this was called the U.S. $1 billion weather and climate disasters product. Now, of course, $1 billion is certainly an arbitrary threshold, but it just so happens that it's a useful threshold because the vast majority of extreme events at $1 billion or more in damage, and we adjust all of this information by CPI for inflation. The vast majority of all weather and climate related disaster damage in the United States at all scales and all loss levels since 1980 actually has resulted from these $1 billion disaster events. Munich Reinsurance, first did this analysis in 2013, kind of looking at the tail end of the distribution. And we also did it ourselves. And it's true. In fact, not only is it true, but it's growing. At the bottom of the slide, you'll see for the first 20 years of this period of record, these billion-dollar disasters roughly were about 75% of the cost distribution for all events using all the available public and private sector data. That grew to 80% of the cost distribution for the first 30 years. And now from 1980 through 2020, it's 85%, actually about 87% of the full distribution of losses. So the 279 separate billion-dollar disasters that affected the United States since 1980 have resulted in $1.825 trillion in damage out of roughly $2.15 trillion. And again, this is actually a conservative baseline, which I'll get into further. So what are we trying to measure and what are our data sources? So certainly there are different ways to measure disasters impact. On the left side, you'll see different perils, different hazards that we focus on: tornadoes, wildfires, inland floods, urban floods, non-tropical floods, of course drought, and also heat waves if they're coupled with drought, snowstorms, hurricanes, of course tropical cyclones of any sort that make impact. But what we don't focus on are geophysical events. That would be earthquakes, tsunamis, landslide type events. Those are not in our database. And then I'd like to direct you to the center part of the slide. The green boxes are really where the crux of the public and private sector data currently exist. And I'll get into that in a bit further detail next slide. The purple and the blue boxes are very important areas that we should all be asking questions about, but the data doesn't really exist, or if it does, it's very heterogeneous in space and time, and therefore we don't want to really incorporate that into our systems. So we're focusing on these green boxes. And so this is really the essence of what those green boxes are. So to capture total direct losses from any hazard event requires, of course, a broad array of public and private sector data. So for more than a decade, we've had a number of non-disclosure agreements and partnerships with insurance and reinsurance companies nationally and internationally. And so this chart, this table I want to show you, denotes the intersection of the different hazards, the 7 types of hazards in the billion-dollar disaster data set at the top versus the data sources on the left. And the X's are the intersection between those. And these aren't all of our data sources, but these are the core data sources that I'd want to highlight mostly. So first, really the gold standard in the United States would be the Property Claim Service. That's an aggregate of thousands of insurance companies around the United States, and they use market share analysis and insurance data from all of these companies and create their own individual state level loss assessments of insured loss for commercial, residential, and automotive damages for certain hazards, but not all hazards. For example, drought or a crop freeze. Also, FEMA's National Flood Insurance Program and Presidential Disaster Declaration data, such as public assistance and individual assistance data, is also very useful, and that's applied to certain hazards. USDA has just excellent data via its risk management agency. It's basically the crop insurance part of USDA. Just wonderful data across many perils at the county level, at the monthly level, insured crop loss data. Of course, the National Interagency Fire Center out of Boise, Idaho is excellent clearinghouse for wildfire information. As is the Energy Information Administration, has a lot of good information for example, in the Gulf when oil platforms are damaged from a hurricane or levee systems are damaged from an inland flood. That data is also available. And lastly, state agencies and even your community, the AASC, provides very important ex post disaster information and context that's often not very clear from some of these other data sources. So everyone and all these different data sources do play an important role. And so essentially from all this data and other data I didn't mention here, we're seeking to capture total direct losses. So that would be the insured and uninsured losses for assets, including the physical damage to residential, commercial, and government buildings, the contents of those buildings, time element losses, such as the time cost for business interruption, even loss of living quarters when you're out of your home after it's flooded and it's being fixed and you can't live there. Damage to vehicles, boats, offshore energy platforms, of course, public infrastructure like roads, levees, bridges, other types of infrastructure is very important to capture. And agricultural assets, crops, livestock, and commercial timber. But it's also equally important to note what we do not account for, which include losses such as natural capital losses, mental or physical healthcare related costs. For example, the wildfires that are happening in the West and the terrible air quality that's happened, in addition to the COVID situation in 2020, that bad air quality and what that does to people's quality of life and you name it, it's very, very difficult to have that data and quantify what that means. So that's another example of a cost that's just too external to our processes. But also all the downstream ripple effects like supply chain and contingent business interruption costs, we don't capture those either because those are more indirect costs. So all that being said, this is a conservative baseline of what we can measure based on the homogeneity of the data across space and time. So let's get into actually what all this data allows us to produce and understand. So this was last year. If everyone remembers, last year was quite a year, particularly if you were in the Midwest. There were 3 major large-scale inland flood events, the Missouri River and north central flooding, the Mississippi River flooding, and also the Arkansas River flooding. In fact, those 3 flood events were 3 of the $14 billion disaster events that happened across the United States in 2019. And unfortunately, those 3 flood events, combined cost of those across the Missouri, Arkansas, and Mississippi River basins were about $20 billion. And about 15 of that 20 billion was due to agricultural damage. And that was approximately 45% of the total losses for all of the $14 billion disaster events that affected the United States last year. But this year is, of course, where everyone's mind is at. This year, I'll show you last year again. Last year, this year. So again, east of the Rockies, we've historically always seen more of these billion-dollar disasters, and that's just simple geography and weather patterns. More severe convective storm systems east of the Rockies. Certainly, the hurricanes in the Gulf and the Atlantic coast states, and things like tornado outbreaks, hail events. Of course, the derecho that happened August 10th across several central states, including Iowa, most profoundly. But I guess the upshot is this map was our Q3 map for 2020, and it already tied the annual record, showing 16 separate billion-dollar disaster events across the United States. Many of those high wind damage events or hail events, a few tornado outbreaks in the Southeast, but also 3 hurricanes. And we can't forget about the drought and the wildfire out west. And since this was produced, we've actually had 2 additional hurricanes. We had Hurricane Delta and Hurricane Zeta, and those are already billion-dollar disasters just looking at the data, but we haven't published those yet. So indeed, 2020 will be a record-breaking year. The question is, how much will we break the record by regarding the number of events? Also, I think it's of note to say that 2020 is now the 4th consecutive year that the United States has been impacted by a slow-moving tropical cyclone, a hurricane that produced both extreme rainfall and damaging floods. Of course, everyone remembers Harvey in 2017, Florence in 2018, Tropical Storm Imelda in 2019, last year, and this year, Sally. And, science is showing us that, more and more of these tropical cyclones are moving slower and really producing prodigious amounts of rainfall and flooding. And of course, that's in addition to the impacts from storm surge and wind and inland rain as well. So, so that's the current map, but our Q4 release will be in early January, and that will provide the full picture of 2020. So here shows another chart we have. This is a time series, and there's a lot going on here. So let me briefly explain. So the bars represent the number of separate inflation adjusted to present day dollars to 2020 dollars, the number of billion-dollar disaster events from 1980 to 2020. The colors you can see at the top represent the type of event they are. The black line is the 5-year cost average for the United States, which you can see in 2020 is at a record level at $106.3 billion per year over the last 5 years. Also, the last 5 years have had in excess of $550 billion of total direct losses from these disasters, which is also a record. And then the spiky gray and red lines show the annual costs and the confidence interval, the uncertainty around those costs. And so certainly one sees this and says, well, certainly we haven't been having that many more extremes. What's behind this? Well, of course, as with any complicated entity, there are several drivers. One, absolutely, we have more exposure, more people living in harm's way. Also, we have more vulnerability. Where we build, how we build. Don't build back to the present, build to the future. And that's something we're all trying to grasp with now, I think. But certainly it is true that climate change is playing a role in enhancing a number of these types of billion-dollar disasters. For example, I'd like to show you, if you look at 2010 through 2020, the dark blue, those would be non-tropical inland flood events. I'm not sure, I think we had maybe 19 of those. We had more in the 2010s decade than we did in the previous 3 decades combined. That's not just exposure. There's certainly an enhanced, a warming atmosphere is a thirstier atmosphere. It can hold more water, as we all know. So I think that we're seeing some signal as far as the inland flood events. And of course, does wildfire season even hardly end anymore in California? Wildfire and western drought, which is already a semi-arid climate, seems like a perpetual cycle ever since the year 2000. It just continues to deliver impacts. And that's where you see the oranges for the wildfires, and then at the bottom, the browns for drought. And again, every year we do go back through our full period of record and add additional historical events, about 5 to 6 old events typically from the 80s and 90s and 2000s that have now in today's dollars reached the $1 billion threshold. So we are trying to make it apples to apples as much as possible. And future enhancements will include adjustments for things like increased exposure, which I'll get to in a bit. Here is another chart. This is a different way of looking at the data. This was last year, and now I'll get into this year's chart. From 1980 through 2019, the cumulative frequency, the cumulative count, the count of these $1 billion disasters, January through December of each year from 1980 through 2019 in this chart. And the black line, of course, shows the inflation adjusted annual average for the last 40 years, which was 6.5 events. And that jumped to 13.8 events over the last 5 years from 2015 to 2019. And you can see the red line was 2019. So, we had 14 of these events, which was well above average and really in the top 5. And again, exposure goes into this, vulnerability goes into this increase, and as does climate change effects. But you can see 2017 was the purple line. We had 16 events that year. 2011 also had 16 events in 2011. And then 2016, we had 15 events. But so here is the latest chart. So again, the black line is the 41-year annual average. And you can see the red line now as the current chart represents 2020. And again, we are tied with 2011 and 2017 regarding 16 separate $1 billion disasters. But in fact, we're above that. We just don't know where we're going to end up yet. So indeed, we'll break the record. Also, let me back up a few slides. I want to highlight the last 5 years show that we've had in excess of 12 separate $1 billion disasters in each of the 5 years. So this is a trend that certainly is not going to change anytime soon due to the factors I mentioned earlier. Okay, so this is the same chart, but instead of the disaster frequency, now we're looking at the cumulative costs for each year as it aggregates January through December. Again, the black line is the rolling average, the rolling average cost for the previous 40-year period. So the 40-year inflation adjusted average for all these events is 43.9 billion. And you see in 2019 again, the red line, it was just slightly above average. It wasn't, it wasn't anything spectacular, and that's because we we were partly spared from a catastrophic wildfire season in 2019, as we had in 2017 and 2018, and again now this year in 2020. We were also last year spared by, we didn't have any truly catastrophic hurricanes like we had in 2017 and 2005, and those are the two outliers you see well above the distribution. The purple line being 2017. Those were the cumulative effects of Hurricanes Harvey, Irma, and Maria, in addition to the Western wildfires, in addition to many other extreme events that impacted the United States in 2017. In 2005, again, Hurricanes Rita, Wilma, and Katrina, and I think it was maybe even Dennis in the mix there, among many other or a few other events. But what I like about this chart is it shows for the United States the distribution. It's really between about $10 and $50 billion per year. And, you look at the outlier years and perhaps why were those outlier years. Also, 2012, that's the third place. That was, of course, Hurricane Sandy, and also the historic drought that gripped about 2/3 of the nation in 2012, among many other events. So the question is, what will this year look like? And that is this chart. So this is the same chart, but now through present. So 1980 through 2020. Now the red line represents this year, and it's a solid line through September, which is when we did our last release. And the dashed red line shows where I anticipate the costs will go, because we have actually not finished costs for a number of the high-end disasters, the hurricanes, the wildfires, even some of the drought impact in the West. Those are still ongoing and will be released at the end of the year. So the question is, it looks like 2020 will probably be a top 5 year as far as costs, and it will be the top year as far as total number of events, at least 18 events. And so what stands out to me this year, and your community, of course, well, my gosh, we've had a hyperactive hurricane season. By the end of this talk today, about 4 o'clock, the Hurricane Center will come out with likely naming their 30th storm. They're well into the Greek alphabet. Of those 30 storms, 12, which is a record, the previous record was 28 events back in 2005. 12 of those 30 hit the United States as some form of tropical cyclone. That's also a record, I believe, breaking the record of 9. And of the 12 that did hit, 5 were billion-dollar disasters. So, and that's also a record. So you can just see how the data kind of stack upon themselves. Of course, also, as I mentioned, we're having another historic Western wildfire season, as we did in 2017 and 2018. And, it's true that the wildland-urban interface and all the people that live, that are populating more and more of the dry ecosystems out there certainly play a role in these wildfire expansions. But, I think that, the historic, perhaps unprecedented drought that California experienced 2013 through 2016, I think it was D4 category for almost 3.5 years solid, and killed 150 million trees, and the bark beetles did the rest. That actually, I think preceded this to set up these historic wildfire seasons, certainly in a way that wouldn't quite be that severe if that drought had not preceded these wildfires as it did. And lastly, of course, the August 10th derecho. That's also, we're still looking at the data with that. That will likely be the most costly single day, convective storm system, thunderstorm system event that the United States has on record. Our Q3 release put it at $7.5 billion. We had an update from the insurance industry, plus the aggregate losses, which are still being compiled. $7.5 billion for that derecho, it might not actually be high enough. It might go a bit higher than that, which actually puts it on par with the April and May 2011 tornado outbreaks, the late April 2011 tornado outbreak across Southeast, and of course the May that impacted Joplin, Missouri, and many other places. So that was quite an extreme, exceptional event, the derecho was. Now, I think the purpose of today's talk is that everything I've shown you so far is just at the national level. But luckily, in this year, we've downscaled all of these different charts and tools and graphs and maps, which I haven't yet to show you, at the state level and even event level. We've even aggregated it at the climate division level. And so this is an example looking at Oklahoma. So like some of the charts I just showed for the United States, this is Oklahoma's cumulative annual cost chart, January through December each year since 1980 for these billion-dollar disasters. And again, the black line shows the annual average, which is about 0.8 billion or about $800 million for the state of Oklahoma. The red line 2020 shows where we are so far this year, at least through September. So you see it's a bit above average. Excuse me, I misspoke. The annual cost average is 0.7 billion, but the 2020 costs are about 0.8 billion. So again, we're slightly above average. But I think what's interesting for planning and policy making and trying to derive what's useful about this information is you're looking at the outliers. What's above the distribution and why is it above the distribution? What happened? So you can see in 2010 for Oklahoma, again, all of this information is inflation adjusted to present day dollars. 3.3 billion. I believe those were just some tornado and severe convective storm outbreaks. 2013, 3 billion, and 2012, 2.7 billion. Those are the three costliest years since 1980. And, you know, geography is everything. In the state of Oklahoma, these extremes are driven largely by drought impacts, you know, inland flooding and severe storms, which would be, you know, tornado, hail, and straight line thunderstorm wind damage. But you can look at this chart for cost or even event frequency for any state you would like, even any hazard division, any climate division. So we're trying to really add some granularity here. Here's another slice. So this is just like the time series I showed you for the entire country, but again, this is just for the state of Oklahoma, 1980 to present. Same setup with the bars and the lines and what they mean. So what stands out here is indeed, you know, Oklahoma is getting impacted by a few more of these billion-dollar disaster events. But you know, again, exposure, vulnerability, and some climate change impacts are all mixed together as far as why. But what stands out, of course, is looks like 2010 through 2013, those 4 years where we had above average costs, but they've come back down. So it's a bit of variability and a bit of randomness regarding the extremes. But you can look at your state. You can look at your climate division. You can actually download this data. I should have put the links, but certainly anyone can email me and ask me questions about the data, and I can try to point them to it after the talk. But again, it's showing a composite of costs and frequency and event type for the state of Oklahoma. Okay, so now let's talk about some of the newer tools and analyses. So again, zooming back out to the national level for the last 41 years, what we find from January 1980 through September 2020 is the United States has experienced at least 279 separate billion-dollar weather and climate related events, each of which are $1 billion in today's cost adjustment damages. So the total cost of this conservatively is $1.825 trillion. But from this table, I've got a few things circled here I'd like to point out. First, it doesn't surprise people that tropical cyclones, which of course are hurricanes and tropical storms namely, they have the lion's share of the losses, about 975 billion of the 1.82 trillion dollars. So about 53% of the total losses come from hurricanes. But the hurricanes are only 17.2% of the events. You see, as of when I took this off the web, we had 48 hurricane events or tropical cyclone events in our database. But now with adding hurricanes Delta and Zeta, which we'll be doing during the next release, we'll be at a nice round 50 tropical cyclones in this data set. And the average event costs for these tropical cyclones are the highest, also at 20.7 billion. So that's not a surprise. But what does surprise people is the top line, which is drought. Drought, the cumulative cost since 1980 is at least 254 billion, with the average cost per event at 9.4 billion. Again, those are the average cost per event is second only to hurricanes. And the total cost used to be second, but as you can see, severe storms at 280 billion just this year has surpassed drought. So we have it's a tight race there. And severe storms also have the highest number of events, which is also not surprising. 126 of the $279 billion disasters are just that, severe storm events. So that's, in fact, that's actually not the full chart you would see if you go to the web, go to our website. I had to condense it and take out some of the columns because it was too much information for a PowerPoint slide. So here's another way of looking at that same data, but I did this in a report I wrote earlier this year. And it looks at the same data in a decadal form. And again, the number and the cost of disasters are increasing for a variety of reasons. It's a combination of increased exposure, increased vulnerability, and the climate change is absolutely playing an increasing role in the increasing frequency and impact of some of these extremes that lead to billion-dollar disasters. So, again, not surprising to see the number and the costs increase from the 80s to the 90s to the 2000s. But it did strike me right after I did this assessment, the difference between the 2000s and the 2010s. As of the time of writing, the 2010s had just a bit more than twice the number of billion-dollar disasters than the 2000s did. Now that's quite a jump. And even the associated costs went from 510 billion for the full decade in the 2000s to 802 billion. And unfortunately, the fatalities also jumped up, but that's largely because of Hurricane Maria and the 2,975 souls that were lost in Puerto Rico from Hurricane Maria. So that's why that number's high. But also, it's a bit striking. The last 5 years and the last 3 years, again, the average number of events, the cost per event, the fatalities, all those are going up. And no matter what the reason is, that's just not the direction we would like to see. So the maps, this is another one of a number of products we have available. So this basically shows that, of course, the entire United States should be weather and climate conscious for good reason, because wherever you are geographically, you face your own unique set of hazards. And so this shows the aggregate footprint of the last 41 years of all of the separate hazards, the billion-dollar disaster hazards, and how they stack up as far as frequency over space and time. So in the top left, of course, droughts, heat waves, it's fairly ubiquitous. Really all of the country is impacted by droughts and or heat waves. But indeed, since the 2000s, the west of the Rockies in particular have had their share of impacts. But the agricultural region in the central parts of the United States, where there's lots of livestock and crops, certainly the cost share is highest there. The winter storms, this is an interesting map. It probably surprises people because of absolutely winter storms happen all over the country. But as far as this is more of an exposure perspective. So it's really the nor'easter events that are the winter storm events that get classified as billion-dollar disasters, because not only do you have large metropolitan centers in the Northeast adjacent to the coast, but these nor'easter events are also, quite supercharged events in their own right, because the damages are, not only the snow and the ice load on roofs, but the high wind, the storm surge, along the coast, the wave action. All of that leads to why the Northeast is the kind of the bullseye for billion-dollar winter storms. Top left, top right panel, you'll see how really everyone living in coastal Texas to coastal Maine could be impacted from tropical cyclones, including those people who even live well inland as hurricanes, rain themselves out. We track that data as well. In fact, we started working with the Hurricane Center several years ago, and they traditionally did not track the costs as hurricanes went inland and became extratropical. We had always done that, and so they started kind of following our lead, and we merged our data sets because, as these hurricanes rain out, and I'll give you an example here in a few slides, Hurricane Ivan from 2004, we want to capture all the costs associated with the full event. Bottom left, non-tropical, so non-hurricane inland flood events, urban flooding, river basin flooding, like we saw in 2019. You can see that map. And again, as the rainfall collects in tributaries and gets into the larger river systems and then dumps out into either ocean or the Gulf of Mexico, you can really see how the bullseye is really most concentrated in the deep South. Arkansas, Louisiana, Texas, it gets the most of the billion-dollar flood frequency events. Wildfires, again, west of the Rockies, including Alaska, not a surprise there. California is the epicenter for the wildfire impacts. But sadly, this year we've seen Oregon and Washington State and Colorado join the list as far as really catastrophic, deadly, and costly wildfires. And bottom right, you'll note severe local storm events. Again, most of the country gets these. This is more of an east of the Rockies just due to how the weather systems play with our geography. But you can kind of see how the mini tornado alleys kind of pop out from these maps. But this is a very high level point of view. So first let's add all these maps together, and this is what you get. This is a cumulative map over the last 41 years. And indeed, you can see the US South, Central, and Southeastern regions face a higher frequency of these billion-dollar disaster events than other parts of the United States. And this reflects the frequency, the diversity, and the severity of all these different hazards that impact these states. So that's a frequency map, and you can see in the key, and you can download this and you can roll over it with your mouse, and it's interactive on the website. But I think the next map is more telling. This is a cumulative cost map over the last 41 years. Again, the U.S. South, Central, and Southeastern regions do experience even a higher cost, as well as a higher frequency of these billion-dollar disaster events. But what I like to compare is Texas and Florida. So Texas leads the way. It's about I can't remember the number. It's more than $250 billion. I think it's 280 billion has been lost in Texas from these billion-dollar disasters. But Texas gets about every hazard, every extreme you can imagine. So it's kind of it gets all of that. Whereas Florida is second place at about 225 billion in losses. But the majority of those are, of course, from hurricane events. And you can look at that data and slice and dice that. But, we don't want to leave out California, New York, New Jersey, Puerto Rico, the U.S. Virgin Islands. We collect data from all of these different territories as well. And, it's important to see absolute dollars, but you also have to put it in relative terms, which we also allow you to do, such as per population or economic size of your state. So as you can see, this is another screenshot from the website. The top left, you'll see we have right now we have 7 different filters, 7 different maps you could look at just from a big picture point of view. Frequency per year, cost per year, cost per event, again, cost per million residences in your state, cost as a percent of your state's GSP, basically the size of your economy in your state. So you can look at any of those maps. You can also choose any combination of the 7 hazards we have up top. Those are like buttons you can select or deselect. You can also choose any consecutive set of years you would like, or you could even look at individual events. So first, before I do an individual event, I'll show you another map. So we'll look at the cost as a percent of state GSP for 1 year. So this was 2019. And if you recall the kind of disaster icon map I showed you earlier in the briefing, certainly the Dakotas and the Midwest were impacted by many different river and flood basin impacts last year in 2019. So this is showing all of the different billion-dollar disasters in 2019 the cost of those relative to each state's GSP. And so, the smaller size of, let's say, South Dakota's more agrarian economy compared to, a bigger state like Texas or Florida, you can see indeed that maybe the actual impacts, the costs were more severe in South Dakota than they were in Texas, even though Texas may have had a higher absolute costs. So this is another example of kind of letting you get into the different exposure and vulnerability angles. And we hope to expand on this more as far as filters around the data. And also going back to the map page, you can see we have all 279 separate billion-dollar disaster. You can look at each individual event, any event since 1980, and filter it by any of the different map types I just mentioned. It's all right there for you to do, and I think you can even download the data. So this is all kind of newer angles, newer features that we've offered this year. So let's look at an example event. For example, in 2004, September 2004, we had Hurricane Ivan. And so in today's dollars, in 2020 dollars, this is a $28.7 billion event. So just as a comparison, the biggest event we've had so far this year was Hurricane Laura, which, as you remember, hit as a strong Cat 4 in the western coastal part of Louisiana, really damaging a number of towns and cities. That was a $14 billion event. In 2018, Hurricane Michael, which hit the Florida Panhandle, was a $25 billion event. So you can see Hurricane Ivan, adjusted to today's dollars, is really comparable to what happened in 2018 with Hurricane Michael. And this is, again, just one of the many maps you can look at for Hurricane Ivan. This is the state costs. You can look at it in original dollars, unadjusted, or in present dollars, adjusted. This is present dollars. And the reason that map looks funny is because of the funny track that Hurricane Ivan took. It was one of the strongest Cat 4, Cat 5s on record at the time. I believe it was a Cat 4 for I don't know how many days in a row. Even though it made landfall as a Cat 3, it had just the inertia, the storm surge from that previous Cat 4, Cat 5 status. That doesn't leave a hurricane once its eye wall winds go down to to a lower level. So it was, just a wild hurricane, and it looped and, looked like some of these hurricanes we've had this year with just some outrageous tracks. And then, of course, the inland flooding, like I mentioned earlier, Hurricane Center often didn't look at inland flooding, let's say when it gets up to Pennsylvania or New York, but those impacts are real, and those are really changing people's lives. So this was the cumulative, the rainfall from Hurricane Ivan. So you can kind of see how and why the cost map looks like that. And again, that's just one map to look at, and we hope to add more later. So finishing up here, I've got only a few more slides. This is another new feature. This is looking at so this is for the United States, and I'll show you a state example in a minute. This is showing the number of billion-dollar disaster events, kind of the climate, just a climatology of billion-dollar disaster events, visualizing how these extremes change over the months. And so for the whole country, you can see that, the beginning of the year is much different than the middle and the end of the year. In March, April, May, June, that's severe weather season, for the eastern third of the country. But June to November is wildfire season and drought season for often the western part of the country. And then August, September, October, it's in the yellow. Those are tropical cyclones. That's bad news if you live on the Gulf or the Atlantic coast with hurricanes. But also we have winter storm events. You can see that happens, of course, in the winter, as does crop freeze events in the aqua color, and then flooding events. I believe if you can see the deep blue, those are non-tropical inland flood events that have happened every month. At least one has happened every month of the year, and that's a bit surprising, particularly in a time like September. But again, the max is March, April, May, June, when you've got snow melt and you've got the seasonal factors that can really produce record-breaking flooding across the central United States. So this is for the United States, but you can also click on the menu and look at your climate region. You can look at Tornado Alley as defined by the Weather Service. You can look at the Gulf Coast states, the Great Lakes states, the Southern Plains. You could look at your own state and see what this looks like for you. So let's look at Florida. Well, that looks a lot different than the United States looks, as it should. Again, Florida, driven by tropical cyclone impacts. It may surprise people that wildfire also has impact in Florida. In fact, a number of southeastern states have been impacted by wildfires. They're not quite the magnitude and scale we see out west, particularly in California, but still they're strong nonetheless. For example, several years ago, Eastern Tennessee had a catastrophic wildfire. But Florida, again, like Texas, kind of it gets a lot of events, but the damage from Florida is largely driven from tropical cyclones. This is just a frequency chart. And so you can see the seasonality of hazards. And then this is also, you can look at this for your state, for your climate region, for the full country. This shows what the UN and international bodies like the World Meteorological Organization are focusing on more and more these days. which are complex cascading risks or hazards. And even, agencies like FEMA have long known that this is really, a very problematic situation where you just get event after event after event, like we've seen in Louisiana. Louisiana has been hit by, I believe, 4 or 5 of the 12 landfalling tropical cyclones this year. That's hard to recover from. So this chart shows basically just that, the compound cascading hazards which can occur from season to season. And so what you're seeing is March, April, May, and June has a much higher likelihood of having multiple billion-dollar disasters across, in any particular space, in this space-time horizon. And also in August and September, you see the same, and that reflects hurricane season. But you should look at your own state and see what that looks like, and it gives you a sense for when a hazard season is high and when hazard season is low. And lastly, as noted in the Climate Science Special Report from the 4th National Climate Assessment, I'll quote, "The physical and socioeconomic impacts of compound extreme events, such as simultaneous heat and drought, wildfires associated with hot and dry conditions, or flooding associated with high precipitation on top of snow or waterlogged ground, can be greater than the sum of its parts." So again, it's not only the frequency, which I'm showing you here, but it's also the cost, the compounding cost, which makes recovery that much more difficult. So these are all different layers of nuance and complexity we're trying to peel back for everyone, because this community, I know, has a lot of similar questions they'd like addressed and like to better understand further. And so here at the top, you'll see that's the URL for the $1 Billion Disasters website. The second link is the report I wrote earlier this year for climate.gov regarding 2010 through 2019, a landmark decade of US billion-dollar weather and climate disasters. And then finally, for a lot more technical depth and background, you can see some peer-reviewed journal articles we had published earlier this decade, or I guess last decade, regarding the methodology, the data we have, the uncertainty. They're at the bottom of the slide. And with that, I'd be happy to take any questions. Thank you.
Thanks, Adam. That was just amazing. All of the different ways of slicing and dicing the data from a geospatial perspective, a geophysical perspective, temporal, spatial, and it's really nice to see the ways in which the product that started almost 40 years ago, how it's evolved, and the many ways that it's been responsive to a lot of the things that we as service climatologists try to provide our various constituents and stakeholders. And even the sort of graphics have also improved, which is great, because it allows us to then sort of cut and paste and take directly a lot of the products that you create directly into the spaces that we work in. So this has been amazing. So I'm actually going to turn it over to Glenn, who's been monitoring the chat to help work through some of the questions that I know have been seeing sort of come up as you were presenting. So thanks again, Adam.
Thanks, Leslie Ann. We do have a question or 3. If something else occurs to you all, you can just say question in there as we're working on the ones we've received already, and we'll get to that. The first question I want to bring on is Karen Bambako. How are you? Can you come on for a second and ask your question?
Sure. Hi. Can you hear me okay?
Yes, perfect.
Great. Thank you so much, Adam. That was wonderful. So I was wondering if you had any information on disasters that are under $1 billion, like on the $1 million scale, particularly at the state level. I'm just imagining that you kind of start to tally them and realize that it's not quite $1 billion. And is that information on the website? Thanks.
Yes, thank you. That's an excellent question. We do have that information. And in fact, that would be one of the upcoming releases I think we can provide as an enhancement to the community. So for example, as I mentioned earlier, I'm going back to a slide. Indeed, when you look nationally, it's true that these $1 billion disasters, again, constitute the vast majority of the cost for the entire data set as it is. But it's also true that there would be a lot of variability from state to state, which is really to your question, because that would provide a lot of value. And so the answer is we have it. We haven't operationalized it yet, but we're trying to think of ways that we could do that. Yeah, we're trying to think of ways to do it. I think that it's just a matter of time. So perhaps in the springtime, we can do another update, and because we've got a lot of irons in the fire right now that I didn't even highlight today. And that would be one of them.
Excellent.
Thank you.
Okay, thanks a lot. And then let me bring Nancy on as well. She had a question about the drought data. So Nancy, would you like to come on and ask your question?
Sure. So you had 3,000, 3,700, some huge number of deaths from drought. And I'm assuming, can I assume those aren't drought? Those are actually heat. Because in the next slide, you mentioned drought and heat, but in the first one, you didn't have heat mentioned. Yeah, this one.
Thank you. Yes, that's a clarification I should have made. In fact, yes, that would be heat wave related deaths during a drought event, which largely that was during the 80s and the 90s. We had those type of events. But yes, thank you for that. I need to fix that.
Okay, thank you. Because of course in Arizona, heat is our #1 killer.
Absolutely, absolutely.
Okay, great. Let me bring Phil on. He has a question about the ITCZ. So Phil, you want to come on with your question, please?
Yes, about when the original work on climate change was being performed, I remember seeing some documents and publications that said the ITCZ could be expanding in its distance away from the equator. I just wonder if some of these more frequent rainfall events and then hurricanes are part of that expansion, or maybe it's not happening, who knows? But anyway, I remember reading that about 20 years ago.
Yeah, I would make a few comments. Certainly, I think a number of recent peer-reviewed literature studies have shown how, particularly in the Atlantic, I know that's different than what you're referring to, but you know, we're seeing a higher latitude and even an eastward shift in some of these development zones for hurricanes. And yeah, I think that there is perhaps a change in the latitude. It's definitely changing the climate. Though the changes you're reflecting in the physical system probably aren't captured in this analysis because, of course, you know, this is just landfalling type events. But that's a good question. I'll have to think about that.
Okay, thanks a lot, Phil. At this point, those are all the questions that we had entered into chat, and we're just under an hour. So if you have that burning question, you're thinking, if there's time, there's a little bit of time. So feel free to come on and ask your question if you have something.
So while we're waiting for that, Adam, if you wouldn't mind going back to your last slide so that everybody could get that URL. I just popped onto it and was able to find all of the ways of slicing and dicing the information that you've talked about in the presentation itself. If there are any tips, tricks, or anything else that you want to maybe highlight at that URL while we're waiting for additional questions, that'd be great.
Yeah, one thing that's missing from this briefing is the links to a number of the data sources. For example, under the maps, like right here, or under the time series, or even under like right here, the time series, there's a link, and we have it in 3 or 4 different formats, and so you can download the data. But I think our one thing I'd like to highlight is, in addition to adding transparency, we're trying to further bring in more socioeconomic data to look at exposure, vulnerability, socioeconomic differences, because those are important questions regarding who is hit and then how they can recover. And, you know, I think that we just want to add more layers of depth to this analysis, but others have also done that. They take this information and they add their own layers, but we're trying to operationalize more of that so then people can skip that step and go to even deeper, more interesting questions. So in addition to that, we also want to, as I mentioned here, bring in more of the right here, bringing more of the physical data within our mapping suite. And so that's also work in progress. So you don't have to jump around to many different NOAA websites. You could look at different physical footprints of information, and then as that layers onto, as that layers onto some of our mapping products. So again, we're trying to make a lot of advances because we understand the community has a lot of questions that would like to get a bit closer to answering.
Right. As you were flipping back through there, I saw a lot of the graphs that David Roth at CPC is involved with creating. So that's great that you're harvesting from that particular data set. Are any of these data available in like shape files or geospatial formats for you to bring in, or are they all primarily table-based or spreadsheet-based?
They are, let's say, we provide them as CSVs, as JSON files, and as XML files, or of course text files, which is like a CSV. So so no, they're not GIS based, unfortunately. Actually, we do want to change our mapping platform, which would allow us to get more into the GIS space. But there's a deeper hardware question. We more of an NCEI question we're trying to resolve before we actually make the switch, because we don't want to switch to a new piece of software if it's going to be if the stability is not going to be 99%. But again, that's these baby steps. We're always trying to incrementally make it better and deeper for and more contextual for users.
Perfect. Does anybody else have a question that they'd like to ask?
All I know, this is Phil in Portland. I've never seen anything like what we've had the last couple of years, especially this year in all my nearly 70 years of watching weather. This is insane. I mean, it's truly remarkable, and the data don't lie here. I mean, and the insurance company saw this coming years ago. So I don't know. Mother Nature is on a rampage right now. She bats last, and she can deal from any part of the deck she wants to. And we just need to survive this somehow. But anyway, that's just my perspective. Is I don't know what she's going to do next, but we got to be ready.
Thanks, Phil.
The only thing I saw left was Nancy had asked about the URL, and I provided the one for the top level billions. Nancy, was that one you were asking about, or something more specific? Okay.
It's ncdc.noaa.gov/billions. This would be /billions/time series hyphenated. This is the home page. Let's see, and this is just summary stats. Let's see, this is /mapping. So we tried to keep it a pretty simple URL. And then finally, we have a /events and then /climatology. But you can kind of see some of the I guess we have 9 sections on the website, or 8 sections, excuse me. So
that page that you're on there, Adam, is the page that shows up when you get to the /billions site, and then you're able to mouse over and choose from what you just said: the mapping, the time series, the climatology, the summary stats.
Right. The /billion, the home page is the overview, and then all of these are different. Yeah, exactly. So
perfect.
Yep.
Yeah, it was just the billion, the first one. If I could get to the first one, then I could go from there. But yeah, I couldn't type fast enough to get what you had on the screen, because then you changed the screen.
Oh, I'm sorry. Let me go back to this. Oh,
okay. I got it. We got it in the chat bot, so I can just copy.
Wonderful. Thank you.
Thank you.
So this was great, Adam. Thank you so much for sharing it and for sort of like peeling back the hood and delving into a lot of the tools that are coming down the pike. I think they're going to be really important for us as service providers, and really nice to see all of the things that are on board and coming on board. So with that, thank you again. Thank you everybody for coming out, and have an awesome weekend. Everybody be safe and be well.